Hello everyone, I am Ali Izzat Kashti. Today's comprehensive lesson is specifically about getting familiar with the RTC and learning exactly how to set the current time and date on an LS PLC system. RTC actually stands for real-time clock, and it is typically found in advanced PLCs that have an integrated internal battery, just like this specific PLC model we have right here. This specific PLC model, the XEC-DR32H, is quite unique. If we carefully remove this protective cover right here, you will clearly see that there is a dedicated battery located inside the PLC unit. So it is important to note that LS compact PLCs that have an internal battery include this feature, allowing us to easily set, maintain, and update the exact time and date on these PLCs for our automation tasks. This is commonly referred to as setting the RTC, and it can have many applications for us. One of its most important uses is that, for example, we can command another device to start operating at a specific date and time, and to stop operating at another specified date and time. Here, as an example, for example, we utilized an LS Industrial Systems G-series frequency inverter and carefully connected it to the LS Electric Compact Programmable Logic Controller. We specifically connected its digital input P1 and common CM terminals, which are directly related to the drive's run and stop commands, to the PLC's transistor output Q0.0 and the common CM terminal. This setup ensures reliable communication between the devices. The drive CM was connected to the PLC's zero common terminal. We connected the drive to the LS PLC's zero common terminal so that we can control the inverter's on and off state from the PLC using this trigger. Now, in the first step, we want to learn together how to set the RTC, and in the second step, we'll write a program so that at a specific time and date, this specific inverter unit powers on and begins operation, and then at a different predetermined and specified time interval, our inverter turns off. So, in order to properly set the RTC in the LS PLC, we first need to open up the XG5000 programming software environment and create a brand new project within the software. We also definitely need to establish a stable communication link with our physical PLC hardware so that we can be able to set the RTC. So after creating a new project, we go to the online menu. Through connection settings, we specify how we want to connect to the PLC. I set it to USB, confirm it, and click connect. Now we are connected to our PLC. If we go back to the same online menu, within the comprehensive diagnostic section of the software, if I specifically click on the PLC information option, a new detailed window will immediately open for us to view. If we then carefully select the PLC RTC tab located here, on this specific page, we can manually set the PLC's real-time clock. In order to successfully set the RTC, as you can clearly see displayed here, there are actually two distinct and reliable methods available for you to use. The first method available involves a process where we manually set the desired date using this dedicated date selection section, and then carefully set the specific time using this corresponding time input section. After we successfully click on the Send to PLC button, our updated date and time will be officially synchronized and set within the system. Alternatively, the second method is that we can automatically synchronize the PLC's internal date and time directly with the current date and precise time of our connected laptop computer. We need to synchronize both of these systems together in unison and make them completely identical. So, for this demonstration, here I am going to use the second available method that we have. If I click right here, a notification message appears and it says PLC RTC is set. I confirm this action, and now the PLC's internal RTC is actually set, and this specific date and time that we are currently observing, as you can clearly see right here, the internal PLC system date and time have now been set exactly to perfectly match this specific current date and time. Now, in order to view the PLC's date and time, we can go into the function here. As you can see, the PLC's date and time have been set exactly to match the current date and time. Now, in order to view the PLC's date and time, we can go into the functions and use a move instruction. Here, I'll search for a move instruction. I can easily enable this specific move function right here in the interface. If I take a moment to click directly on the input section of this move block and then navigate further into the detailed flag section, we will find several options. Within these flags, we have a very specific flag called RTC time of day. This is exactly the one we are looking for to complete this configuration process successfully and ensure everything is set up correctly for our needs. By selecting RTC TOD, if I click right here on this specific option, you will see that it automatically gets set in the input section of our move instruction block. This particular flag is designed to read the current internal time from the PLC for us. So if we want to perform a check to read the PLC's system time right now and carefully verify whether our PLC's internal clock is set correctly or not, we can easily use this flag to retrieve that data. This ensures our time-based logic remains perfectly synchronized with the actual real-world time. We can certainly do this, and with the helpful assistance of this specific flag, we can accurately read and monitor the current time. Now, moving on to the output section, I am going to use a variable called out, and its specific data type must definitely be set to time of day. So this is an absolutely critical and essential point to remember. The data type used here must be time of day. If we were to set anything else in this field, the software will immediately give us a configuration error and will not function correctly. If we do not handle this correctly, an error will inevitably occur during the execution of the program. So to prevent this, here in this specific section of the logic, I have utilized the RTC time of day function. I carefully read the current system time from the real-time clock and then move that value into a dedicated variable called out, which has been specifically configured with a data type of time of day. Now that the logic is complete, I will proceed to enter this single line of code that we have just written here into the PLC memory for processing. Activating the monitor, you see we're reading the time. It matches my laptop at 10:39. I've moved this value into the out variable. I have the time exactly here. Now I'll deactivate the monitor mode. This time we want to read the date together, that is the date on my laptop. We want to see if this date has also been transferred to our PLC or not. So once again, we go into the functions. Here I search for move. This function is also... If I take the cursor and click right here on this specific menu option and then navigate all the way back into the configuration flag section once again, this time I am looking for the setting labeled as underline RTC underline date. If I carefully place this specific flag right here in this position, you will notice that the previous date information that was displayed before will start to behave differently within the system interface. Using variable out1, the data type must be date to read the date correctly, otherwise the program will error. Now I'll re-upload to the PLC. I now activate its monitor, and here you can see very clearly that we have both the current time and the specific date. January 25th in the year 2026, which is exactly the same date you see right here, January 25th, 2026. Now, as I carefully explained to you at the very beginning of the lesson, we can use this precise time and date for our next steps. We can use it so that we can give a command to a device and, for example, tell a device to turn on at a specific date and time and turn off at another specific date and time.